Thanks for tuning in at Brackies.
Hello everyone and welcome to the third video on making a multiplayer FPS in Unity. In this video we're going to be putting aside making the character for a bit to focus on networking. So we'll finally add some networking functionality to our game. That means that we'll set up a network manager and instantiate a player prefab into a networked scene. And we'll also talk a bit about local player authority and those kind of concepts. And I'll be making a short presentation on how UNet actually works in terms of programming and how clients connect to a server and all that kind of stuff. So before we get started, I quickly want to mention that I've now added the multiplayer FPS tutorial project to GitHub. So if you want to download any of the files or the entire project, you can go here. Links are in the description. And if you want to have the exact version that I'm currently on or a previous version, you can go under commits here, and I'll try and name these according to the video. So there should be a version saying video 3, video 4, and so on. And there's also a test branch that you can use if you want to see what I'm working on for future videos. Also, I've gone ahead and completely redone the donate system. I thought it was really bad before, and a lot of you guys have said that you wanted a better way to kind of support the videos. So you can go to brackies.com/donate and fill out the forms here if you want to make a donation. It truly helps me out a lot. And yeah, so thanks a lot, and let's dive into today's video. So let me start by explaining a bit about how UNet actually works. So I've made this model here that displays kind of how UNet is split up into two APIs, application programming interfaces. The first one is the high-level API, and this is what we are going to be using. This provides a bunch of classes and methods that we are going to be using to apply networking to our game. The high-level API, HL API, is built on top of what is called the transport layer. This is much more bare bones and low level, and this takes care of a bunch of stuff behind the scenes. So the transport layer can be directly accessed, but that's not something we are going to be doing. And basically, this takes care, the high-level API connects to the transport layer and takes care of stuff like distributed object management and state synchronization, along with a lot of other stuff like message queues and all that. So if that sounds very technical to you, well, then you're in luck, because that's not something we need to care about in our instance. So the transport layer gives great control, but it's also very technical, and therefore we'll be fine off by using the HL API. So on top of the HL API, Unity has gone ahead and made some components for us. For example, we have the network manager, the network identity, the network transform component, and a bunch of others. And these are basically suggestions by Unity of how you could implement the HL API in your game. So these do a lot of stuff for us, and they are going to need to be customized in some kind of way. So basically what we're going to be doing later, not in this video, is we're going to override or extend these components to create our own custom scripts that has exactly the functionality that we're going to be needing. We might add on to these components or decide to do stuff in a different way that makes more sense. But basically, these don't need to be used at all. You can create a game, a multiplayer game, by only scripting or making your own components that communicate with the HL API. So that's kind of how the UNet programming functions. And basically, if we take a look at how the networking in Unity actually works, well, UNet is based off of the principle that one of the clients, meaning one of the players, is the host. So you have seen this in a lot of games. For example, Call of Duty uses this principle of naming one of the clients the host, and if that client then leaves, another client becomes the host. So this is a pretty neat way of doing things, because basically we have this client here called the local client, because that's part of the host. And we have also the server sitting on the same machine. And this machine then has an IP address, and here I've just used a sample IP address. This is what an IP address could look like. And then all of the clients or all of the other players that want to connect to this host, well, they basically connect to that IP address, to the server, which then connects locally to that client if needed. So let's say that this client wants to shoot this client. Well, he connects to the IP address, to the server, and the server connects back to that client. So if this client needed to connect to this client, well, he maybe shoot that client by going to the IP address, going through the server, and then the server will talk to the client here. So everything goes through the server, which sits on the host's machine. Cool. So now that you have this understanding, I might present to you a problem because, well, a lot of modern games don't use this kind of IP address. You don't want to be typing in an IP address every time you want to connect to a player. I mean, if you want to play over the internet, you want some kind of matchmaking system. And when using this kind of setup, we have some issues with firewall preventing connections and all that. So to solve this, Unity has created a matchmaking service which is called the Unity Relay server. And here, all of the clients connect to a server that is hosted by Unity, which then communicates to the host. And that means that Unity takes care of IP matching, and it solves issues with firewall and NAT configurations. And you don't need to know exactly what this means and how it's solved, but just know that we won't have any issues with connecting that will have to be solved by the clients. They can just connect. And this is not something we are going to be integrating today. It is something I hope to integrate in a later video. But basically, Unity hasn't released or announced what the prices on using this will be. A very common thing to do is have a limit on the number of concurrent users that you can have on this system before you need to pay. But Unity hasn't released any information on this, so I won't go ahead and say anything yet about what this will cost and how many users you can have for free, if any. So we'll see about that. But for now, let's focus on setting up some networking locally on this machine. So the first thing that we are going to be doing here is adding the central networking component by Unity. So let's create an empty game object over here, and let's call this the network manager. And that's without a T. Let's reset the transform on this and just drag it to the top of the hierarchy there. Let's go ahead and hit an add component here, and let's add the network manager. That's the one. And this basically is a component made by Unity that can do a bunch of different stuff. Well, it sets up the scene here to do networking. And you have a bunch of different info here on how you want this set up. And for now, we can ignore this. And you also have the ability to use this component for spawning in players. So you can add a player prefab here, which is what we are going to be doing. So we have this a network manager, and we also have a network manager HUD. And what this does is right now when we hit play, we see that, well, nothing has really happened, and we just have this player and he's not on a network in any way. So let's just go ahead and drag this player into a prefab and then delete him from the scene. And now let's look at the network manager. Well, basically we need some way of interfacing with the network manager script. And Unity has created this component that we can use while testing called the Network Manager HUD. So this creates a head-up display and you can enable it and disable it here. And you can also play with the offset if you want it someplace else on the screen. And this will just give us a UI that will allow us to connect using the Network Manager. But we need to add a camera here, which will show the scene when we are not playing. So when we don't have a player yet and we are in kind of the lobby where we want to choose what we want to connect to, well, then we want to have some kind of camera that just views our level. So let's right click here and hit create camera. Let's reset the transform on this. And let's rename this to maybe scene camera. Let's also make this the default camera. So let's tag this as main camera. And let's drag it up and out. Maybe up some more. And let's rotate it down to view our scene. And I'll just switch to global up here. And that looks okay. Whoops, I screwed up the rotation here. So that's 0, 0, 0. And then rotate it down on the X. Something like that, and you can see in the game view here how that looks, and I think that's going to be fine for now. I might drag it up a bit more and then rotate it along the Y, and I think that looks just fine. And you can see here that our skybox looks very boring here, so let's change this from skybox to solid color, and let's just make this some kind of gray or deep blue here, just temporarily at least. We'll make it look something like that. It's going to be fine, and this looks a bit washed out, but we'll have a look at creating some more awesome graphics later. And we want an audio listener and all of that on this component. So now that we have that here and we save the scene here and hit play, you can see that the Network Manager HUD is now displayed here, and we can choose to either create a host here or join as a client, and then we specify an IP address. A local host here is just the name of a certain IP address, meaning on the local system. And you can also choose server only, which we are not going to be messing with right now. So, and you can see here we can enable the matchmaker. We'll get into all of that stuff. So now that we have that, we can select LAN host here, but it says that we have to add a player prefab. So let's go ahead and do that. So inside of our network manager, we have this spawn info tab, and we have this player prefab slot. So let's go ahead and drag in our player, and it will give us an error here. It will say that the player prefab must have a network identity. So this is another component created by Unity, and the network identity is a component that we add to all networked objects in our scene. So stuff that we want to communicate on the network in any way are going to need a network identity component. So we add that, and it has two toggles here. The first one is server only. We don't want that because we are going to control this player. So we want it to sit on the local client. And then we have local player authority. And this makes sense for us because we are controlling the player locally on our system, and then we are sending the movement information and other stuff out through the server to the other clients so they can update it on their systems. And therefore we want to check this local player authority because we have the authority of the movement locally, and then we send it out through the network. Cool. So we can clear the console there. And that's basically all that we need to add in order to add it to the network manager slot. So we'll just drag it in there on the player prefab, and we'll have auto create player prefab, and we have the ability to specify where we want the player to be created, because right now it's just going to be created on this 000 mark, so in the middle of our scene. So let's instead add a few objects, or at least two, for where our player will be spawned. So let's create an empty object here, and let's name this spawn point. And let's just add a component to this. And if we search network here, we find the network start position, and that's just the only component that we need to add. And let's also create a gizmo for this. So let's just select an icon here and maybe make that blue. And you can see now that it says spawn point here. So we'll just have it sit on 0, 0, 0, then set the Y to 1 because we want him to spawn a bit up in the air. And the blue arrow here is probably the way that the player is going to be facing. So let's give this an X amount, a Z amount of -5. Duplicate this, rename this to spawn point 2, and let's rename this to spawn point 1. And maybe just drag this down so they're right by each other. And we can maybe actually make them a child of the network manager. So spawn point 2 here, we are going to set the Z to 5, and we are going to rotate him 180 degrees on the Y. Whoops. And if we change this to local, you can see how that worked. So now these two objects are facing each other, and they are 10 units. They have a distance of 10 units. So this way we can go into our network manager, and we can change the player spawn method to round robin. And this will basically first choose one of the spawn points, and then the next player that creates will just choose the next spawn point and the next one, and then loop. So when we only have 2, this will make sure that we will switch between the 2, which is pretty cool, because then we will also always spawn opposite of each other. Cool. So now that we have this in place, we can go ahead and hit play on this, and we can select LAN host, and we are spawned into the scene. But we get a small warning here saying that there are 2 audio listeners in the scene, and that's because our scene camera is still active. And if we were to go ahead and try and build this, and let's actually do that now, there will be a couple of issues. So if we go to File, Build Settings, and just add in our main level into the builds list here. And 1 second, my phone is going off, so I'll just turn that off. So we add this to the list. And now basically we have to select the target platform. I'm going to build for Windows. 86 and development build is fine. And then we can hit build and run. And we can choose some place to build it. You can see I've made a test build here already. But basically I've gone into my project folder, created a folder called builds, and just named this one build 1. Now hit save on that, hit yes to replace it. And it's just going to build here, and it should go pretty quickly. And once it's done, it's going to open up the window here. I'm just going to select windowed and maybe a bit smaller of a client here, and then hit play. And we get this window, and now we can hit play in the Unity here, and these basically represent each or 2 different players or 2 different computers or clients that want to play with each other. So on the first one here in Unity, we can select host, and we get dropped into the scene, and here we can select client, and you can see now that we are facing each other, and this actually was rotated wrongly, but we are standing opposite of each other and staring down each other's barrel. And that's awesome. However, you can see in Unity right now it's complaining that there are 3 audio listeners in the scene, and that's because we have on this local client here, we have both a camera on the one player, a camera on the other player, and the scene camera. And there's another issue with this, and that is that the player motor and controller is enabled for both the players on both the systems. So when I go ahead and move here, you can see that the other player is moving too. So both players are responding to input. And that's of course something we need to take care of. But there's one more issue, because if we go in here, neither of the players have moved. So, what is going wrong here? Well, basically, we need to kind of disable the components that sit on the other objects, meaning the ones that are not controlled by the system, so that we don't affect other clients with our input. And also, we need to kind of network how the movement should go. So we need to add some kind of component that will transmit our position and rotation over the network. So there's a bunch of stuff we need to do here. And in order to kind of set this up, we create a script. Let's call this the player setup script. So under the player here, we'll add the player setup, new script, and let's just make that of type C#. And in this script, if we double click it to open it up in Visual Studio, basically we are going to be creating some lists for objects and components that we want to disable when they're for all other players in the scene than the one that we control. So I hope that you can follow me on this. So let's just remove the using system collections namespace. We are not going to be needing that. And then let's just remove these two methods for now. So let's start by creating a list of components that we want to disable. So let's make this an array. So all components in Unity are derived from behavior. So if we want to kind of make this very general, we could make the a reference to the player motor, the player controller in each their variable and then disable them. But I'm just going to create this array so we can just add in any kind of component and don't need to add anything to the script each time. So let's make a behavior here, and that's going to be an array. And let's call this our components to disable. And let's close that off. And then in our start method, basically what we want to do here is we want to check if we are on the network or if we are the local player. So in order to do this, we need to access Unity networking. So first off, we need to include the namespace up here. We need to be using unityengine.networking, and all of the high-level API sits within this namespace. But we also need to derive from network behavior. So this will allow us, this script, to act as an object that is networked. And we'll have the API up here. So now basically all we need to do is check if we are not is local player. So if is local player is equal to false. So if we are not the player or if this object isn't controlled by the system, well then we want to go ahead and disable all of these components. So we'll just loop through that array. So we'll say for int I equals 0, I is less than components to disable dot length I++, and then we want to say components to disable dot enabled, we want to take the ith and set that equal to false. So basically what we're doing here is we're saying in the start method, when the player spawned, we want to check if we are controlling the player, and if not, well then we want to disable all of these components. So we basically loop through the list and set the component that we're currently looking at enabled state to false. Cool. So that's basically all we need to do in scripting here. We could also start disabling the camera, but let's do that in a sec. So let's minimize that. And you can say that there's a warning here saying that it will never be assigned to, and that's because we need to mark this as a serialized field. So that will allow us to access it in the inspector here and assign stuff to it. So now the player setup when multi-object editing is not supported. There we go. So that just needed to update. You can see that we have this network channel and network send interval information, and that comes when deriving from network behavior. That can just be ignored. But we also have this array. And let's just increase the size on this. We want to disable a bunch of things. So if we are not controlling this object, well then we don't want to have a motor, and we don't want to have a controller, and we do not want to have some kind of camera, or so we want to disable the camera component, or an audio listener. So those are the components that we need to disable. But these components sit on another object, so we need some kind of way of dragging them in here. And for the camera, that's pretty simple. You can simply drag the object in here, or add him to back into the scene, and then browse here and simply drag the camera in, and that will simply drag the first component that sits on the object into the slot. But how do we access the audio listener? Well, that's actually pretty simple. We can go ahead and lock this inspector. So now that we select another object, it's just going to stay on that object. And then we can create a new inspector. So we hit Add Tab, Inspector, and let's just drag it over here. And that is going to change unless you log it. So now we can go on the camera here, and we can take the audio listener and drag it in there. So you can just keep the inspector here, or you can just close it here. I don't think we're going to be needing it again in this tutorial. And then we can unlock this. So now that we have these components to disable added, we can hit Apply, and we can delete the player. And we can try this out, but I assure you this should be working. So let's just go ahead and add some functionality for disabling this scene camera. Well, basically, when do we want to disable the scene camera? Well, we only want to disable the camera if we are the local player. So we don't want to disable or enable the camera each time another player joins. We want to disable this local camera when we join. So therefore, we can simply add an else statement here where we disable the camera. And because we marked it as a main camera, remember we added the tag there, we can simply say camera.main.gameObject.setActive and set this to false. So that's all we need to do. And in the future, we're not going to be doing this under the player setup because the camera, the scene camera doesn't really have anything to do with the player. But for now, we can just add this functionality here. So that's basically all we have to do. But we also have to re-enable it once we disconnect. So in order to do that, let's make a reference to this camera first of all. So let's make a camera variable here, and that's just going to be private. And let's call this scene camera. And then here in the start, we'll set, okay, I'm just going to write this again. We'll set scene camera equal to camera.main. And then down here, we'll say that if scene camera, so if it's actually found a camera, it's not going to be equal to null. And then we can simply say scene camera dot gameObject.setActive, and then we can disable it. So this will make sure that even though it doesn't find a camera, we don't get any errors. And then if we want to re-enable this, we can use the handy function provided by Unity called onDisable. And this is also called when the object is destroyed. And in here we can simply say that if scene camera is not equal to null, well then we want to say scene camera.gameObject.setActive and then true. So then we enable the object again. And this of course uses setActive. We could also just enable the component, which might be something that we want to do. But on enabling and disabling the whole object, we don't need to do anything with the audio listener. So this is going to work just fine. So that was all for the player setup script. Now let's save this and build this. And building the player here. And by the way, the shortcut that I'm using is Control B. Let's hit play on this and play in the game. And let's select host and select client. And we need to turn here. You can see now that we are not getting any errors in the console. And if we inspect in the hierarchy here, the scene camera is disabled. And the player that we own has both its player motor and the player controller and its camera. But the other player here doesn't have any of these components enabled. So this means that when we now move in the game, we are the only one moving. However, it still doesn't update. So we need some kind of way of sending this information over the network. And that's what we're going to be looking at in the next video. So that was basically all for this video. I hope you enjoyed it a lot and were able to follow along with the concepts. If not, you're gonna get the hang of this. Don't worry. Networking is very different from other kinds of programming and can be pretty hard to get a grasp on, because you have to kind of think of so many different players connecting and interacting with each other. So I hope that this made some kind of sense. And if you couldn't get the programming side to work, of course, check out the GitHub page. It's called Multiplayer FPS Tutorial, and there should be a link in the description. And if you enjoyed this series a lot and want to support me, of course, you can go to brackeys.com/donate and make a donation. It helps out a lot. So I hope to go full time in the near future, and this is the kind of stuff that helps me do that. So thanks a lot for watching this video, and I'm looking forward to seeing you in the next one.